I'm Troy McClure. You've seen me in such fine quality, epic chemistry educational videos such as, what does molecular shapes have to do with it? And, do bent molecules do things the rest of the molecules can't? Part 2. Okay, this is a review within the chapter talking about how do you predict molecular shapes. And that's the whole point of this video. So, let's get started. But we have to look at what are the basic molecular shapes that we have. Okay, that's our basic molecular shapes. They have linear, trigonal planar, pyramidal, tetrahedral. Okay, those are the ones that you are responsible for. So for linear, it could be 2 or 3 atoms that are arranged in a straight line. Now, trigonal planar is 4 atoms in a flat triangle. That's where planar meaning flat, trigonal meaning triangle. Fairly straightforward. Pyramidal, you've got 4 atoms that are in a pyramid shape. These two, there is a way that they could get a little bit confusing, but we're going to resolve that. Now, tetrahedral is pretty straightforward. It's 5 atoms in a shape that's got 4 triangular faces and 4 corners. This is the best way to describe it. So let's go on and let's go with some specifics. So let's look at the linear with the 2 atom one. Anytime you have 2 atoms, it's automatically linear. It doesn't matter if it's H2. It doesn't matter if it's O2. That doesn't matter. But on the other hand, you could have something like this. So these are all examples of linear molecules. All these are linear molecules. Anytime you have 2 atoms together, it could be the same or it could be something different. So we can look at O2, we can look at H2, okay? All those here. Now you may notice I used some dot diagrams up here, which that'll be a subject of another video. But anyways, this is what the 2 linear atom molecule looks like. Okay, so anytime you got 2 atoms, automatically linear. Now, what about the linear 3 atom? Are 3 atom molecules automatically linear? No. Some could be bent, but there are those that can be linear. So what would that look like? Well, let's look at carbon dioxide for a moment. So here's carbon dioxide, good old CO2. How in the world do I know that this is in fact linear? And that's the trick. How do I know that this thing isn't bent? The reason why I know that this is linear and not bent is that if you look here, these are dots, electron dots. These are the bonds that the electrons make between the atoms. Another way to look at them are electron concentrations. You're going to see that on your test. You're going to see the phrase electron concentrations. Okay? So these are unpaired electron concentrations. These are bonding electron concentrations. Now there's 2 here, which means that there are 4 electrons involved in this bonding concentrations. Okay? So if you notice, look at the central atom, and if you notice, there are no unshared electron concentrations there. There are none. They're totally occupied, which this is why we are seeing what we are seeing here. Okay? So this is a straight line. And of course it's nonpolar, but that's a subject for another video. Okay? But that is the linear 3 atom. So when you're on the test and you're looking and you see a question, whereas 3 atoms in a molecule, you can automatically eliminate things like the pyramid, tetrahedral, the trigonal planar. Those can be eliminated automatically. You can narrow it down to linear, like this, or bent. Okay, so let's go on. If you notice, again, no unshared electron concentrations here.
whoops. So let's look at trigonal planar here for our next one. 4 atoms only. So trigonal planar could either be 4 atoms. Okay, it's 4 atoms, I'm sorry. It's 4 atoms only, but that could also be a pyramid. Again, how do we tell? Again, we're going to be looking at, look at the center atom, if there are any unshared electron concentrations. Then yes, this is going to change. This is going to be not a flat triangle, it's going to be a pyramid. But this is a flat triangle. How come? Boron can only take 6 electrons maximum. That's why. 2, 4, 6. Okay? 2, 4, 6. Those are the number of bonding electrons that we have here. Now, what else will work with this? Well, we have another one here where we can have boron trichloride. That's another trigonal planar. Absolutely, it can be. All right, so these are 2 examples of trigonal planar, 4 atoms only. Now, let's look at pyramidal. Pyramidal, on the other hand, you have 4 atoms, but you have 1 shared electron concentration, just one. 1 pair of electrons that are not shared. What would be an obvious one for this? Well, NH3 is a classic, okay? So if you think about it, nitrogen has 5 electrons to it, okay, and you have 1 pair of unshared electrons. This is the unshared electron concentration right here. Unshared, that means it's not connected to another atom. And then here we have the bonding electron concentrations that are there. Again, bonding electron concentration means we have electrons here that are involved in connecting our hydrogen to our nitrogen. So this is what's going on. Now some of you might be thinking, but wait a minute, how is this different from here? Because you've got 4 atoms, it's either going to be trigonal planar or it's going to be pyramidal, but I can't tell the difference. You can tell the difference. Because here, boron, in this case here, has 6 electrons maximum. That's it. So that means there's no unshared electron concentrations out here. Here, nitrogen, max of 8 electrons. Now that's a very important thing. Nitrogen has a maximum of 8 electrons to it. So here we have an unshared pair. What is that doing? Remember that VSEPR, that valence shell electron pair repulsion theory. What's going on? The electrons are pushing down on those hydrogens, those electron concentrations that are bonded between the hydrogen and the nitrogen. So instead of being flat, like our trigonal planar, okay, because these are flat, right? If I were to look here, that's what it would look like. Nice and flat. That's what it would be. But because we have that unshared pair electron concentration, that forces the hydrogens down. It's forcing them down. So that's why, whoa, hey there. That's why, ladies and gentlemen, we get the pyramid shape, not the flat shape. That's because of these. That's what's happening. It's forcing it down. But you'd say, but wait a minute. Why wouldn't they be down totally? That's because you also have the electron pairs that are involved in bonding the nitrogen and the hydrogen. They also push against each other. Plus, you have the protons of the hydrogens pushing against each other. Everybody is pushing against each other. and there's some point where they're equal. That's this. That's the equal point, okay? Because you have forces that are there. What are the forces? Electrons repelling each other according to this theory. You also have the protons and the hydrogens pushing against each other as well. So this is why you're seeing the shape that you're seeing here. Okay? Now, let's go with another one here. Let's go with tetrahedral, and then we'll work with bent. So tetrahedral, 5 atoms with no unshared electron concentrations. This is pretty straightforward. CH4, that's a classic. Here, SiH4, that's another one. But let's look with the CH4 here. Carbon maxes out at 8 electrons. That's the maximum it can hold. And that's a pretty important idea. So if we look at carbon, this is what it looks like. Now some people would say, but wait a minute, isn't this a flat square? That's a square planar. No, it's not. The reason why it's not, ladies and gentlemen, is because these hydrogens need to be as far away from each other as possible. So what you're getting is you have a hydrogen here, you have a hydrogen here, you have a hydrogen in the back being pushed, and another hydrogen. So remember, again, that whole idea. You have the electrons that are pushing away from each other as much as possible. That's that VSEPR thing. You also have, at the same time, the protons, that one proton inside of each hydrogen atom, that is also pushing against each other. So we have some repulsive forces. That's why this is tetrahedral. But a quick thing, if you got 5 atoms, it's tetrahedral for us here. There's one more I need to go on with you guys, and I didn't write it up, and that's bent. Bent is 3 atoms with unshared electron concentration. So that's the first thing about bent. Now, what would be some obvious ones? Okay, well, dihydrogen sulfide is a classic because again, sulfur maxes out at 8 electrons. Okay, so for sulfur, you have 2 of them being for hydrogen, another 2 being for the hydrogen. Okay, so that takes care of several right there, but you also have this. These are the unshared electron concentrations. So if you're thinking like this, oh yeah, this could be linear, kind of like CO2, but if you notice, you go back to CO2 for a moment. Look at CO2. There's no unshared electron concentrations. The electrons are involved in the bonding. We go to bent, there's the difference. Because these guys are pushing against each other. Remember that VSEPR, valence shell electron pair repulsion theory, okay? That's why you're getting a bent shape like this. And you want to know another example of a bent shape? We all live on it. We all depend on it. Water. This is why water is the Mickey Mouse molecule, because otherwise it would be like this, but with those unshared electron concentrations, it's forcing it down. And that's why you're getting the angle that you guys have. So, at this point, ladies and gentlemen, we've covered the basic molecular shapes, how and why they are the way that they are. Think valence shell electron pair repulsion theory, and at this point, I bid you farewell. Have a good day.